Hello, hello. I'm recording notes so that you will have me teaching you a lesson while I am gone at my funeral for my neighbor. And so here's what we're going to do. We're going to take notes on 6.2. Just so you know, the part that you're writing down is this information right here. And then you have 1, 2 examples that I have picked out for you. And that's what you're going to do. So, substitute teacher, what I would like for you to do is I would like for you to press the enter key in just a moment, and that will pause the video so that students can write down this information. After they're done, go ahead and press enter now. So now coming back to what we are doing here on 6.2, I'm hoping we're ready. Let's talk about what you wrote down and how you're going to use it. What we talked about in 6.1 was we talked about proportions and ratios. What we're going to do in 6.2 is we're going to be talking about how two polygons can be similar and that their side lengths will be proportional. Two polygons are similar. Do you see this little wave? Oh, I don't know why that showed up. Let me go here to a pin. There we go. When you see this little wave symbol, it means similar. So if you want to, you could even change out the word for this little wave symbol that looks like that, and that means similar. Whenever you see that, similar. If the corresponding angles are congruent and the lengths of the corresponding sides are proportional, then the two polygons are similar. This is kind of like the definition of how you know if something is similar. Something similar, their angles have to be congruent. All of them. Every single angle has to match. Their corresponding ones have to be the same. That means as each other. And the lengths of the corresponding sides have to be in proportion to each other. There are shortcuts to it, but you won't learn those until we get to 6.3 and 4 and 5 and so on. So, few other things we just wrote down. Similarity statements must be written in corresponding order, meaning the triangle on the left or the quadrilateral on the left needs to be in the same order as the quadrilateral on the right. As long as the angles match in the similarity statement, that is how the correct way we're going to be doing things, and I'll give you an example in a little bit. All corresponding sides of similar polygons simplify to a value called the scale factor. Most of your math will be involved finding what this scale factor is. So you finish writing down those notes. Let's do some examples and then give you some time to do the homework. This is number 13. What we normally do is we do a question like this. They are welcome to do it in their books. And so if you want to pause while students get their books out, that is fine. Coming back, if students have their books, they can do this in their books. They don't have to do this in their notes. What we look at, are the polygons similar? This is number 13. If they are, write a similarity statement and give the scale factor. Well, how do we know if things are similar? The first thing, they're similar if the corresponding angles are congruent. Let's look. Double arc. Oh, no. Double arc, these two things match. Triple arc, it means those are congruent. Single angle, congruent. Right angle, congruent. All the angles match. Perfect. Are all the sides proportional? Well, how do you check that? You check by checking the sides. I'm going to check this side compared to this side. Is 24 over 16? Is that the same proportion as... let me draw this. 24 over 16, 18 over 12. Is that equal to 18 over 12? That's my question. Is it equal to 12 over 8? Is it equal to 24 over 16? And I just chose to go left over right. You do not have to do that. You could choose to go right over left as long as you're using corresponding sides. So there's my check. I'm checking. Let me see here. Let's reduce these and see... what's what? Divide by 8. Divide by 8. Divide by Question mark. Divide by 6. Divide by 6. Divide by 4. Divide by 4. Divide by 8. Divide by 8. What do you notice about all of these things? They are in the same ratio. What is that ratio called? That is called the scale factor. What this scale factor is, that actually answers our question right here. It's the scale factor is that the left polygon is 3 halves as big as the right polygon. It is 1.5 times bigger than that one, if I change that to a decimal. That's what the scale factor is. Okay, so let's answer these questions. Are the polygons similar? Are they a proportion? Are all the angles the same? Yes, they are similar. So yes. I'm going to write down yes. This is my first answer. If they are, write a similarity statement and give the scale factor. So the similarity statement, I have to write these in order, and I'm going to recommend that we go in alphabetical order. I'm going to go D, E, G, H. D, E, G, H. We don't have a symbol for this quadrilateral, so we're just going to leave it like that. D, E, G, H is similar to, and now the D has to match. That's what we're talking about here. Similarity statements must be written in corresponding order, and the angle and the congruent angles must match. That's what I'm talking about. The D has to match with which one? I'm hoping you see that letter there. I believe it's a P. I might need to erase that to find out. Let me erase just a little bit. Oh, yeah, it's a P. The E matches with L. The G matches with Q. Corresponding angles. Do you see how that works? And H matches with R. We have, yes, polygons are similar. Similarity statement and give the scale factor. The scale factor is 3:2. And you can write it, remember, as a fraction, or you can write it with the colon. Sometimes you write it with the word, but 3:2 is just fine. Got it? Last example. Number 31. You're welcome to do this in the book. Find the value of x, give the scale factor of the polygons is the directions. And it says triangle WLJ is similar to this triangle. These two triangles are similar. They have the same angles and their sides are proportional. So what does that mean? That means that we can actually figure some things out with both of these things. The first thing I'm going to do is I'm going to go, oh, this is isosceles. If this is x, LJ must be x. And since this is BV is 5, then BQ must be 5 as well. Why? Because of isosceles triangles. Now, I want to set up some proportions, and here's what I'm thinking of. I'm thinking of BV is proportional to LJ. BV is proportional to LJ. I'm using the similarity statement and the picture. Just so you know, they're kind of flipping this triangle upside down if you can't tell that. That's why you don't just assume that 5 and that x were matching. Sometimes in the similarity statement, they do some things where they switch things around. This is how you can tell for sure what's supposed to match. So I'm going to do 5 over x. This 5 over that x. And I want to figure out what this other value is. I'm going to use, I went 5 over x, and I'm going to use equals 8 over QV matches with WJ, which is the x plus 6. And so, since that is how we set it up, then what I'm going to do is I'm going to cross multiply and you do their cross products. Means, extremes, subtract the 5x, question number 1, find the value of x. We've done it. Second question, always go back and read the question. If there's nothing I don't teach, if I teach you anything this year, I always want to make sure I'm teaching you to read your directions. That's something that is overlooked way too much these days. Give the scale factor of the polygons. So remember, they started with this WLJ first and the QBV second. So we're asking what the scale factor of this one to that one, this side to that side. So now that we know that this is 10 and that's 10, we can just use two of the sides. It doesn't matter what if I plug it into the bottom, which I could if I wanted to, 10 plus 6 and get that 16. Well, what's the scale factor? You take whichever one they started with, the one on the left is 10, and I'm going to compare it to its other side. This 10 is WL is proportional to that QB, which is 5, 10 to 5. Is that in simplest terms? Is that in lowest terms like I mentioned to you before? No. So what is the scale factor is 2 to 1, or simply, let me simplify that, 2 over 1 would also simplify just to 2. The scale factor is 2. That's twice as big as that one. We're going to stop your notes right here. It just all depends whether you have the check sheets or not, but I'll put it right here on the board for you if you need it. Page 354, numbers 11 through 14, comma 16, comma 18 through 24, comma 31 and 32, and then 37. Whoa. You can't even see that, huh? Let's move it over there through 40. You can press pause right there, but I am done with this recording. If they need that, there you go. Give them a little bit of a break and then give them the next set of notes. Thank you.